This is Drew, who went through an unexpected fire accident that practically destroyed everything. Honestly, the place was a complete disaster. The floor was charred, the ceiling was collapsing, and the only thing the remains could be used for was firewood. The real problem was that he was living in the peak of the Canadian winter, and snow had filled the entire house, as you can see. Without question, his dog would have died if he left things as they were. Believe me, in this video you'll find a kind of enjoyment you won't see anywhere else on YouTube. From roofing, insulation, and finishing touches to crazy details that we'll witness later, like the house being fully heated and him controlling everything from his phone. He started with building the base that the house would rest on, using cedar wood. He set up 4 beams and covered them with planks of the same type. He chose cedar because it withstands harsh weather conditions and looks much better than treated lumber, giving the house a modern touch with its distinctive orange color. After about an hour, he had completed the whole base and then added some extra supports beneath the house to hold the insulation that would be installed later. Next, he began installing the planks. To keep the spacing precise, he used popsicle sticks, and he secured each plank with 2 2-inch screws into every support beam, ensuring strong stability. The last plank, however, turned out to be a bit wider than needed, so he measured it, cut it with a reciprocating saw, and then finished the edge with a 1/4-inch round router bit so it would match the edges of the other planks. Once the floor was finished, he flipped it on its side and installed the insulation underneath. He used solid 2-inch insulation panels, cut them so they were 1/2 inch smaller on each side, and then secured them with expanding foam to fill in all the gaps, ensuring the house would be well insulated once placed on top. With the insulation done, it was time to move on to the frame. He used 2x4 lumber, the same type commonly used for wooden house framing in North America. For the bottom plate of the walls, however, he chose cedar or redwood so it would resist moisture and not rot if rain ever leaked down from the roof. Next to the door opening, he added another piece of 2x3 wood instead of 2x4. He designed it so that one side would have a 1-inch recess, leaving the inside hollow to later add a decorative feature that would look amazing. He made 3 of the walls 24 inches high, while the 4th was 30 inches, allowing him to create a sloped roof with a slight incline. This design prevents water from pooling on top and helps direct runoff. He then secured the studs to the base using 3-inch anchor screws, placing one every 12 inches to ensure the frame would be firmly held together. With that, the base and walls were completed in exactly half a day. Since the floor was going to be heated, he needed to run electricity to it. He brought a 50-foot cable, cut off the female end, and connected it directly into a junction box that would power the entire house. This way, whenever the plug was connected to an external power source, everything inside would work. He installed 2 4-inch electrical boxes, cutting an opening into the bottom plate of the base and running the cable to the first box. He added another box on the wall, threading the wire through all of them and connecting each lead together with wire nuts. Finally, he safely closed the boxes. Next, he brought in the heating panel designed specifically for laminate floors. Installation was very simple. He just unrolled it, cut it to size, and connected it to the thermostat. The thermostat he chose had Wi-Fi, allowing him to control the temperature from inside the house instead of constantly going in and out of the doghouse to adjust it. The first step was installing the temperature sensor in its designated slot on the thermostat and securing it properly. From there, he only had 4 wires to deal with. He connected the black and white wires coming from the wall, then connected the black and white wires coming from the heating panel. After finishing the wiring, he attached the thermostat's front cover, plugged the cable into the power supply, and tested the system. Once he completed the initial setup and testing, everything worked perfectly, and the readings confirmed that the heating system was operating at 100%. At this point, he removed the next heating panel to prepare the floor beneath it. He carved out a few channels in the floor to bury the wires neatly, then sprayed foam into all the gaps to completely seal the space against any leaks, whether air or water. For reference, this heating panel is waterproof, so there would be no issues even if a little water came in through the door or other small openings. After that, he laid down 2 layers of insulation under the panel to improve heating efficiency, then secured the panel back in place. Using adhesive tape, he fixed the temperature sensor 1 inch away from the panel's edge. Immediately afterward, he installed the flooring above it to protect it from any damage during the rest of the work. Here, he chose vinyl tiles because they are 100% waterproof, meaning he wouldn't have to worry if the dog walked in wet or dirty. Next, he sealed the gaps around the door with silicone to prevent water from seeping under the floor. For lighting, he decided to install small spotlights in the ceiling, but he wanted them to switch on automatically with the power. To achieve this, he cut into the main AC cable and connected a SmartLine switch, allowing him to control the lights easily from his phone. He applied the same method to the exterior LED strip. Using the original 12-volt adapter, he cut the plug off and connected it directly to a 12-volt inverter, so it could run straight from the main source instead of needing an external connection. After wiring the cable to the inverter's output, he soldered the smart switch onto the AC input so that the power cable coming from the junction box would feed directly into the smart switch. This way, he could also control the LED strip easily from his phone. After that, he organized everything neatly and secured both circuits inside the second electrical box. These two circuits would power the ceiling spotlights as well as the LED strip, which he planned to use later to illuminate a decorative feature. With the wiring, floor heating, and lighting completed, he moved on to cutting the wooden supports, marking a straight line across the wall. He needed to raise the pencil slightly off the surface, and he found that a USB cable was the perfect height, so he used it as a spacer. Then he cut the shape with a power saw to make sure the wooden support fit properly on the wall. By setting the square ruler on the line he had drawn, he could mark small reference points, which would help him replicate the same angle easily on any board without having to measure every single time. Once he confirmed that the measurement was correct, he marked that piece and used it as the main template for all the others. Using it as a guide, he cut 5 or 6 additional supports of exactly the same size, then set them aside to focus on the work for the interior walls. He had bought plywood panels measuring 8 by 3 inches, which he found at Home Depot for a bargain price of about $35 each. He started cutting each panel according to the wall dimensions and used an air stapler with 18-gauge nails to secure the panels to the walls. The work turned out excellent, clean, and precise. On one wall, he created a 3 by 6-inch maintenance opening, allowing easy access to the smart switches in case any wiring issues occurred later. This was a very practical solution that saved him from having to remove an entire wall just to fix something. After fastening the panels, he applied white filler to seal the seams, ensuring everything was tight and neat. With that, the interior work was almost finished. Next, he moved on to insulation. He used the same solid 2-inch foam panels, and before installing them, he filled in the gaps around the edges with expanding foam to make sure the insulation was airtight. Once the foam dried, he trimmed off the excess. He then covered the entire external frame with house wrap, attaching it temporarily with tape before stapling it securely around all the edges. He also applied sealing tape over any openings he had made to guarantee the insulation stayed strong. Finally, he prepared an exterior cladding board for the shed, giving it 2 coats of white outdoor paint to protect it from the elements and give the structure a polished finish. After the silicone had dried overnight, he began cutting the panels to size and fastening them onto the walls. For this, he used 1.5-inch galvanized brad nails to secure each panel firmly in place. He only covered 3 walls on the inside, leaving the last one unfinished, since it would later be clad with cedar panels once the roof was installed and everything was in position. Next, he brought in a budget window he had bought from Amazon for around $30. This window was originally designed for boats and yachts, but he managed to repurpose it here. The window came with screws that allowed it to be opened from the outside, a clever feature since it meant he could use it as a summer ventilation opening. Fresh air could enter through the door and exit through the window, reducing the heat inside. He measured the window's size on the wall and cut out the opening using a jigsaw. Then he used a long drill bit and a square template to reduce the opening on the inner wall, ensuring that everything fit to the millimeter.
Before mounting the window, he ran a bead of silicone around the entire frame to prevent any leakage. After pressing it into place, he secured it with screws in the pre-drilled holes. However, there was one problem. The window didn't come with an interior trim frame to cover the edges. To solve this, he 3D printed one, which took about 3 to 4 hours. Once finished, he installed it in position and sealed it with silicone. After that, it was time for the roof. He began by placing the main roof panel over the side supports. Once he was certain that everything was properly aligned, he marked its exact position on the supports. Then he removed the roof panel, set it down on the ground, and screwed it into the supports. He added extra braces to increase the roof's rigidity and secured everything with 4-inch screws, drilling pilot holes first to prevent the wood from splitting. Finally, he started attaching the front fascia board to prepare for the rest of the roofing. Using a square, he carefully aligned the mounting points, fastening everything with 2 screws per stud. The roof was beginning to take a strong, straight shape. From there, he installed the angled fascia board, aligning it flush with the wall below, then took precise measurements with a tape measure and laid the next piece on top. To make sure the line was perfectly level with no tilts or unevenness, he installed reinforcement blocks around the roof in the spots where the fascia boards and soffit would later be attached. This provided solid anchoring and prevented any shifting during installation. After trimming the edges flush with the fascia board, the roof was fully prepared for the next stage. He then moved on to finishing the exterior cladding. He brought cedar siding boards with a tongue-and-groove system, meaning each board locked into the next. These boards were 6 inches wide, and he started covering all the walls that hadn't yet been clad, continuing seamlessly up across the entire roof. He carefully aligned the first board to make sure it was perfectly level, then fastened it with galvanized nails at both the top and bottom, preventing expansion or contraction from ruining the look over time. He followed the same method under the roof, working board by board. At one point, he noticed that if he kept the same measurements, the last board would end up much thinner, about ½ an inch, and would look awkward. To fix this, he decided to slightly reduce the width of the first board, which gave more space for the last one, resulting in a balanced and consistent appearance without any odd-looking gaps. After finishing the wall cladding, he repeated the same process under the roof, creating a uniform look that matched from the roofline down to the wooden siding of the walls. Since he had a few extra boards left over, he decided to use them to cover the base edges, hiding the rough cuts and giving the entire structure a cleaner, more polished look. For this, he used brad nails, which provided strong fastening without being visible on the surface. Next, he installed the door frame, made of cedar or redwood. At this stage, he wore a mask because he was moving on to sanding. After sanding the entire doghouse, it was ready for finishing and protection. He used Olympic wood stain in a natural cedar shade, applying it to all the exposed cedar surfaces. This not only protected the wood from moisture and weather damage, but also gave it a rich orange sheen that made the final result look very elegant. He mentioned that he loved the way it looked already, but he was certain it would look even better once the roof and fascia boards were painted black. Before starting the painting, he cut a few boards, each measuring 1¼ inches wide, to use later for paneling and decorative finishes. He decided to paint them all at the same time so they would look consistent and wouldn't need any touch-ups afterward. Before closing off the ceiling, he chose to install the lights. That part was simple. He cut evenly spaced openings in the wood, then slid each light into its place with ease and connected the wiring using IC connectors. Now, when it came to the ceiling, he had never built one before, so he expected a few mistakes. He started with the aluminum drip edge he bought from Home Depot, aligning its first end with the edge of the roof. Then he cut the other end with scissors. At first, he used regular scissors, but later switched to tin snips, which he found much easier. He secured the drip edge with roofing nails, placing one about every foot. After that, he moved on to the side pieces using the same method, marking the cut line, drawing it out, then fixing it first with a single nail, adjusting it with the drip edge, and cutting off the extra piece. Here he made a mistake. He should have cut along the entire line as he had seen in all the YouTube videos, but instead he tried bending it around the corner. In the end, he had to cut it again. He also made another major mistake. He should have installed the insulation layer before putting up the side drip edge. So he had to undo everything, install the insulation first, and then reattach the drip edge all around the ceiling. After that, he began installing the shingles, or the front covering. Originally, he considered using a metal roof, but that would have been too expensive for a doghouse, so he decided to go with standard shingles. He cut starter strips from full shingles and placed them along the roof edge, leaving a 3-inch overhang on the side. Each shingle was secured with 4 nails, spaced about a foot apart. Then he started laying full rows of shingles, making sure the ends of each one didn't overlap directly with the seams below. He aligned every new shingle carefully with the ones beneath it. He secured each shingle with 4 nails, and after finishing each row, he trimmed off the excess. For this, he used one of the spare shingles as a cutting guide, then sanded all the edges smooth. Each new row was offset by 6 inches to the right, and he kept repeating the same pattern until he reached the peak. Once he trimmed off the excess at the top, he took those cut pieces from the right side and reused them, installing them all over again. Of course, this step was done to create a staggered, zigzag pattern across the roof instead of having all the seams line up evenly. When he reached the peak, he trimmed off the extra pieces and then used an aluminum strip measuring 4 by 1¼ inches to cover the top edges. He marked the roof lines on each side, cut them with tin snips, and left a small overlapping flap on the side so it would cover the drip edge properly. After that, he applied 2 lines of sealant and fastened the strip with nails, about 1 every foot. The last step for the roof was installing the fascia. He bought a strip from Home Depot, but it was wider than needed since it was designed for 2x6 lumber. So he trimmed off a section to cover the gap that was still exposed in the wall. Luckily, the measurement turned out to fit perfectly with the folded lines. He bent it at a 90-degree angle to close off the back edge. As mentioned earlier, this fascia was made for 2x6 lumber, but since he was working with 2x4, he just trimmed a small piece to make it fit. He also cut a small notch so it would wrap neatly around the vertical wall, leaving a tiny tab that he folded over to give it a much cleaner look instead of leaving a rough edge. After marking the cut lines, he left about an extra inch rather than cutting exactly on the line. This allowed him to slide the fascia under the drip edge, then fold the 1-inch overlap at a 90-degree angle to wrap smoothly around each corner. For the last 2 pieces, the process was simpler. He just cut them to exact size, though he did have to trim off a small section. So that each piece would fit neatly on top of the other without any issues, he slid them into place under the drip edge and secured everything with aluminum nails. After that, he applied black silicone to seal any visible gaps or exposed screws, ensuring the finishing looked clean and precise. For the final touches, he decided to create a simple cedar wood decor, separated by hidden LED lighting. He closed off both the upper and lower sections and started installing the LED strip. Since its adhesive wasn't strong enough, he reinforced it with a bit of silicone to make sure it would hold firmly over the long term. Then, he brought in the wooden panels he had stained earlier and began installing them evenly around the walls, keeping the spacing perfectly aligned down to the millimeter. These were leftover wood pieces, so he painted some of them black and white to decorate the door and parts of the house. To make the setup more efficient, he used these plastic strips, typically used for maintaining temperature in hockey rinks and skating rinks, cut them to the length of the door, and fixed them with a wooden panel. This way, the temperature could be preserved inside during winter when the heater was running. After all of that, the mission was a success. He managed, thankfully, to save his dog and built him a dream house. The LEDs looked like they were flickering in the video, but that was just because of the camera's frame rate. In reality, the light was steady and perfect. As for temperature, on a normal winter day when it was -6 outside, the house maintained around 10 degrees inside, which was almost ideal for his dog, especially since, by nature, it has thick and heavy fur. So there was no need to make the space too warm. All the lights were connected to Wi-Fi, so he could control them from his phone as well as adjust the thermostat from anywhere. The entire house consumed less than 100 watts of power, costing roughly $30 to run, and it was only used for 3 months a year. That made the overall cost very reasonable. The project was fun because it was finished in a short amount of time, and the final result looked stunning.
He admitted it might have been a bit extra for a doghouse, but said it was a great learning experience that taught him skills he could use in future projects. In fact, anyone could scale up the design and build a storage shed or even a small cabin using the same techniques he applied here. As for the cost, the entire project came to $1,400. And finally, if you liked the work, don't forget to subscribe to the channel. Thank you.